Okay, so we'll have some time. All right. So now why? So in general, given some expressions like what you call polynomials like this, you should be able to figure out which one is larger or faster, I mean lower time complexity than the other. Okay, so here we're given some sample functions that will most frequently come up with this course. So n is say the input size, 10, 10 square and so on. Log n. So, and computer science people, computer engineering people use base 2. Okay, so log n always to the base 2 for analysis time complexity because eventually things are stored in binary. Alright, so log n, 10 to the base 2 is 3.3, log 10 squared to the base 2 is 6.6 and so on. So as you can see the numbers, log n is much slower than n, right? So as n increases, log n also increases, but it increases at a very slow rate. So if you're given two algorithms, so this is also n, same as input size, so n, 10, 10 square and so on. So if there are two algorithms, one is of time complexity n, the other is log n, you should prefer a log n algorithm because it grows very slowly. Okay, so like the divisions, if you do 10 million or sorry, 1 million division, 10 to the power 6, and if you do 20 divisions, you should go for an algorithm that does 20 divisions compared to 1 million divisions. Okay, so log n is always the preferred time complexity for from an algorithm point of view. Now log n is smaller than n. Now what about n log n? So you're multiplying n with log n. So that means n log n will be more than n, right? So actually the sequence here, they are like increasing order. So log n is less than n and n is less than n log n, as you can see the numbers. Then you have n square. So since log n is less than n, n multiplied by something less than n is going to be less than n square. And you can see the numbers. N square, 10 million, it's a 10, 10 square is this, 10 square is 10 to the power 4 and so on. So these numbers are going to be less than n square. And n square multiplied by n is going to be less than n cube. So as n square, this is n cube. Now, one thing common for all these terms that you have here is they are polynomials. In the sense that in a polynomial, the variable, which is n in this case, is not in the exponent. So what you have in the exponent is a constant, 2, 3, in this case n to the rise to 1 and so on. And even log n and all these things, the n is not in the exponent. So that's what is called a polynomial. Whereas this is 2 to the power n. So the variable n is in the exponent. So this is not a polynomial. This is an exponential function, 2 to the power n. And you can see if n is 10, 2 to the power 10 is like 1024, which is close to 10 cube. Then if n is 10 square, 2 to the power 10 square is like very large number. So exponential is not a preferred time complexity for your algorithm. Similarly, n factorial. So a factorial function is also not a preferred time complexity for an algorithm. As you can see, 10 factorial is this, 10 square factorial is this, much even larger than exponential. So exponential and factorial functions are not preferred for time complexity. So something you should know. Okay. Let me check. What time is it? Alright, so we'll stop with this. This is a separate topic. We can start from next time. So let me take your attendance in the meantime. This is a class of 55, so 39 are logged in, so it will take the rest of the class time. Alright, so let me see your names as, so don't log out until I say you can log out, so I can mark your attendance. stop this recording.